Okay, today we'll start introductions to probability and basic concepts on probability. This is the first class on probability. So, actually, what is probability and why we need probability? We'll discuss today. What is probability? Probability is the measure of how likely an event or outcome is. Okay, different events have different probabilities. Actually, in cricket match of Bangladesh and New Zealand, we have to make a toss for the winner of bet. Okay, then if we toss, if the toss happened with the umpire, then there will be head or even head or tail. So two outcomes. One is head or tail. So both the team will not win, but one team will win. This is the actually probability of winning for the tossing. So how do we describe the probability? We can describe the probability of an event with the following terms. Certain, the event is definitely going to happen. That means after tossing, we will get a result of the event. Another one is likely. The event will probably happen, but not definitely. That means it may rain today. Okay, it may rain today, but may not also. This is why it's look likely. Unlikely, the event will probably not happen, but it might. Not happen, but it might. That means it is unlikely. Impossible, the event is definitely not going to happen. That means tomorrow will rise the sun on the west. Actually, sun rises in the east, you must know. Means if tomorrow will rises the sun in the west, it is actually impossible. So impossible event is definitely not going to happen. You must know these four key words for the probability. And to describe the probability, we must introduce these four. One is certainty, another is likely, and another one is unlikely, and another one is, last one is impossible. That means impossible event. Certain event, you must know certain events, that means it will 100%. Okay, certain event means actually sure event. Okay, sure event. And impossible event means actually it will not happen. Okay, then the probability of certain events, remember the total probability will be 1. Highest probability is 1. That means 100%. If we represent as a percentage, then it will be 100%. But impossible probability, the probability of impossible events will be 0. Remember it. So the lowest probability is 0 and the highest probability is 1. That means all the probabilities, if we describe any probability, we have to indicate it between 0 and 1. That means the probability will lies between 0 and 1. So 1 will be the probability of sure events and 0 will be the probability of impossible events. Remember it. Now, what is probability? Actually, the probability is the measure of how likely an event is. Okay, the probability is the measure of how likely an event is. Actually, likely, there are 4 parts we have discussed. One is certain, other is likely, and another one is third one what? Unlikely, and another last one is impossible. These keywords, 4 keywords, actually we are using in our everyday of life, in every ways of life actually. So this measurement actually is called probability. So the classical definition of the probability will be the ratio of the number of favorable cases to the number of all cases. Actually, probability of E can be written as number of the outcomes favorable to E and number of all possible outcomes of the experiment. Suppose we are tossing, the umpire is tossing at a game, cricket game, but the two team doesn't know who will actually bet first. So after tossing, they must know a result. Okay, this is why, suppose if we toss a coin, there will be two outcomes. One is head and another is tail. So the probability of coming one head after tossing, what will be the probability? Actually, number of outcomes favorable to E, that means event. After tossing a coin, head, how many head is there? Actually one head. Okay, and how many total outcomes, what will be? Head and tail.
Yes, sir.
Okay, so today we'll discussing actually the introductions to probability and basic concepts of probability. Actually, in everywhere we are using probability in our for our daily necessaries. Suppose in any game, actually in any cricket match, any football match, you have to toss for the winner of bat fast or bowl fast or kick the ball fast. So to start the game, we have to depend on probability. And for our to be a successful man or to be a successful students in any university, you have to depend on probability. You may be success in a period of time. You may be successful in a may not be successful also. Okay, so there we discuss actually 4 keywords for that. One is certain, other is likely, another is unlikely, other is impossible. So remember these 4 key words for the probability. Probability, actually, what is probability? Probability is the measure of how likely an event is. The classical definition will be the ratio of the number of favorable cases to the number of all cases, or probability of E can be written as number of the outcomes of the favorable to E, number of all possible outcomes of the experiments. Okay, so suppose if we toss a coin, there will be 2 outcomes. One is head and other is tail. So the probability of getting one head will be what? 1 by 2, because number of favorable outcomes what? Only one head, and total outcome what? 2, because one head, other is tail. So total will be for a coin 2. Suppose we are tossing a dice. Actually in dice, total outcomes what? 6. So and probability of getting 1/6 from the event of a dice. So how many 6 there? Only 1/6, and total number of outcomes what? 6. So for getting 1/6 from a dice, the probability will be what? 1 by 6. Suppose the probability of suppose you are tossing a dice and for getting an even number from the dice. How many even numbers here in a dice? 2, 4, 6. So 3 even numbers. So for getting even from a dice in an event, the probability will be 3 divided by total outcomes what? 6. 3 divided by 6, that means half. Remember it. Similarly, for getting an odd number from a dice, odd number, how many odd numbers there? 3 odd numbers, 1, 3 and 5. So 3 odd number there. So favorable outcomes what? 3 odd number, and total sample space, total outcomes what? 6. So for getting any odd from a dice will be 3 by 6, that means half. So generally the word probability is used in our day-to-day conversation by the coming across following the statements such as probability it may rain today. Okay, watching on the sky, we can say it may rain today. Actually may not also, maybe. Okay, likely or unlikely or certain or impossible. That means 4 words may be happen with these 4 words. So he may possibly join politics. Suppose we are guessing someone, he may possibly join politics. Actually, certain, may be certain, may be likely, may be unlikely, may be impossible. Suppose Indian cricket team has good chances of winning World Cup. Okay, if we take this statement as, that means for this statement the probability will be 4 steps. One is maybe, certain, certainly, or likely, or unlikely, or impossible. These 4 events happen. So in these all statements, the terms probably, possibly, and chance are used by us. So which conveys the sense that there is uncertainty about what has happened and what is going to happen, and therefore the term probability can substitute the word uncertainty, and impossible, likely, unlikely. Remember it. Impossible or uncertainty, same words. More precisely, the definition of probability. Probability is a concept which numerically measures the degree of uncertainty and therefore of certainty of the occurrence of events. Okay, any events. If an event A can happen in M ways and fail in N ways, all these ways being actually likely to occur, then the probability of the happening of A is can be written as number of favorable cases divided by total number of mutually exclusive and equally likely cases. That means numerically you can represent M divided by M plus N, total number of space, and this is the favorable cases, and total number of cases will be M plus N. This is actually a definition of that. Remember it, total number of, if the probability of the happening is P and the probability of not happening will be Q, so total probability will be what? 1. Remember it, P plus Q will be 1, and P is the probability of success and Q is the probability of failure. So the sum of probability what will be? 1. Remember it. Now, for instance, on tossing a coin, I have discussed it. The probability of getting head, what will be? Half. Why half? Actually, in a coin, you must know only one head. And total outcome what? Head and tail. That means 2. Total outcome is 2, and getting a head will be, the probability will be half. And there are different types of definition related to probability. Suppose die. Die, you must know it is a small cube dots. 1, 2, 3, 4, 5, 6. There are 6 outcomes, okay, marked on its faces. And cards also, you must know there are how many cards? 50. How many cards there? 54 or 56. How many cards? You must know. And exhaustive events or sample space. What is sample space? The set of all possible outcomes of a single performance of an experiment is exhaustive in events or sample space. Each outcome is called sample point. Suppose in a coin tossing, we get head and tail. So sample space can be written as H, T. H for head and T for tail. So, and there are random experiment. There are experiments in which results may be altogether different, even though they are performed under identical conditions. They are known as random experiments. Suppose tossing a coin or throwing a die is an experiment. Just if the umpire in a game, if the umpire toss a coin, it will be an random experiment. Okay, so suppose trial or event, what is will be event? Performing a random experiment is called a trial. This is the actually trial, and outcome is termed as the event. So there will be an outcome after tossing. Umpire will declare the winner of toss. Okay, so these events actually is called trial or event. Tossing a coin of is a trial, and the turning up the head or tail is an event. Just turning up the head or tail is called event. Remember it. Equally likely events. 2 events are said to be equally likely if one of them cannot be expected in presence to the other. Suppose we are getting head, then tail will be absent. If we get tail, then head will be absent. So this is called actually equally likely events. For instance, if we draw a card from a well shuffled pack, we may get any card. Then 52 different cases are equally likely. Independent events. Two events may be independent when the actually happening if of one does not influence any in any way the probability of the happening of the other. Suppose the event of getting head on first coin and the event of getting tail on the second coin in a simultaneous through of two coins are independent. Actually, we are taking two coins. This is why the events are independent. Remember it. And mutually exclusive events. Remember most important definitions in probability. Mutually exclusive events. What will be the mutually exclusive? Two events are known as mutually exclusive when the occurrence of one of them includes the occurrence of the other. That means, for example, we can say on tossing of coin, either we get head or tail, but not both. That means the outcomes will be different for different events. This is why it is called mutually exclusive event. Or if there is no common element in space, if there is no common outcomes in an event, it is called mutually exclusive events. And compound events, what will be? When two or more events occurs in composition with each other, the simultaneous occurrence is called compound event. When a die is thrown, getting 5 or 6 is a compound event. Suppose if we throw a dice, what will be the probability of getting 5 or 6? Then it will be compound probability. Suppose we are try to get what will be the probability of getting an odd number after throwing a dice. Odd number, how many here? 1, 3, 5. There are 3 odd number. This is why it will be called compound events. And favorable events, the events which ensure the required happening are said to be favorable events. For example, in throwing a die to have the even number, suppose 2, 4, 6 are favorable cases. So this is the actually example for favorable events. Now, conditional probability, most important probability. The probability of happening an event A such that another event B has already happened. That means A depending on B. Remember it. A is depending on another event B. Then it is called conditional probability of happening of A on the condition that B has already happened. It is denoted by probability of A if B happened. It is read as probability of A if B happened. Probability of A if B already happened. Remember it. Odds in favor of an event or odd against an event. This is actually if the number of favorable OS is M, number of not favorable events is N. So odd will be M by N, odd against will be inverse and divided by M. Actually, this is the formula we have to use in solving different examples of probability. Now, classical definition of probability, what will be? Actually, if there are an equally likely, mutually exclusive and exhaustive of events of an experiment, and M are the favorable, then the probability will be small m divided by capital N. Capital N equals to actually total number of space, and small m will be the favorable space. So expected value, if P1, P2, P3 dot dot Pn of the probabilities of the events, individual events, x1, x2, x3, x4, xn, then the respectively the expected value will be, expectation of x will be just multiplication of probability and events. P1 multiply x1 plus P2 multiply x2 plus P3 multiply x3 plus dot dot Pn multiply xn. And it can be written as a summation because all are sum are equals to 1 to n PR xr. Remember this, we have to use this formula for solving different kinds of probability. Okay, now loss of probability. There are two laws of probability, namely additive law of probability or theorem of total probability. Another one is multiplicative law of probability or theorem of compound probability. So there are two types of probability laws. Now, first one, the additive law of probability for mutually exclusive events. Additive law of probability for mutually exclusive events. Actually, mutually exclusive events means two events will not happening altogether. That means all are happening independently. The probability of one of the several mutually exclusive events, A1, A2, dot, dot, AK. How many probability here? K number of exclusive events will happen is the sum of the individuals probabilities of the separate events. Symbolically, you can say the probability of events A1 plus A2 events plus dot dot AK events, sum of all events, okay, will be equals to individual sum of each probability of each events. That means probability of A1 events plus probability of A2 events plus dot dot probability of last one events, that means AK events. So probability of all events equals to probability of sum of all events, individual probabilities of the events. So we can have to prove this. Let n number of total number, let n be the total number of exhaustive, equally likely and mutually exclusive cases of which M1, M2, dot dot MK are respectively the favorable number of cases of the events A1, A2, dot dot AK. That means first events A1 has M1 cases. How many cases? Total cases M1. And A2 events has M2 cases. And last events AK has MK. So for n number of events, there are n number of cases. Remember it. And mutually exclusive. Remember it. There is no multiplication. That means no intersection will be happening. There will be no common elements between more events. Since the events are disjoint, that means disjoint events, there is no common element between two events or more. That is the non-overlapping. Then the total number of cases favorable to the events either A1 or A2 or dot dot AK. That means either means what? Actually, or means you must know we use in set union for or. So for union we have to take
non-overlapping bolte ki bujhe?
That means there is no disjoint. Disjoint means what? Not happening altogether, individually happening. This means what? That means not overlapping. Overlapping means what? Actually happening altogether. So non-overlapping means what? There will be no jointed, actually disjoint events. This is why non-overlapping. Now total number of cases what will be? M1 plus M2 plus dot dot MK. Total number of cases. You must know from the definition of probability. Probability of all events equals to the favorable events. Favorable cases
Yes,
what?
sir.
M1 plus M2 dot dot MK, and total number of cases. Total number of cases is n. We have taken this total number of cases n. So according to the definition of probability, favorable cases divided by total number of cases. Now we can write this M1 divided by n plus M2 divided by n plus dot dot
MK
plus
by n.
MK divided by n. But this is the probability of
A1,
events A1,
okay.
and this is also the probability of A2, and dot dot this is the probability of kth event AK. Okay, hence it is actually proved the theorem. Very easy for you. I hope if you try to understand, you can easily understand this. In a set notation, you can also write just
union issue diyo mone na?
Plus. We can use union for plus.
Yes, sir.
Okay, just in set notation we can apply this formula for this case. Now additive law of probability for not mutually exclusive event. That actually not mutually exclusive events means what?
So
Some events will happen conjugately. That means there will be common events.
Yes,
okay,
sir.
The probability of one of the several not mutually exclusive events, suppose A1, A2 dot dot AK, is given by probability of all sum of all events will be equal to I equals to 1 to K probability
Summation.
of AI summation minus summation I and j, where ij are not equal. Okay.
Yes, sir.
Up to k, probability of ai as a plus dot dot minus 1 to the power k minus 1, probability of a1, all happening altogether. A1, a2 dot dot ak. All are happening altogether. That means there is no, there is a common element of for all events, common elements. That means compound events. So we have to prove this. This is actually theorem for not mutually exclusive. Now to prove this, let us consider two not mutually exclusive events. Suppose a1 and a2 are taking, just we are taking only two events. One is a1 and other is a2 initially. Since the events a1 can occur either of two exhaustive mutually exclusive events, likely this a1 and a2. That means happening altogether. The two events happening altogether, a1 and a2. Or a1 happening not a2, where a2 bar indicates not happening, complement of a2. Okay. Then probability of a1 will be what? Probability of a1 and a2 happening plus probability of a1 happening but not a2 happening. We can write this as a formula from set theory. This is equation number. Similarly, probability of a2 will be what? A1 and a2 happening altogether, probability of that plus probability of a1 not happening but a2 happening. Okay, then this is another probability. So in set notation we can write this is the first events a1 and big ball is the a2. So a2 is bigger. Okay, so this part is the common region. This is the common, and common is denoted by a1 intersection a2 or a1 into a2. Okay, a1 intersection a2 means what? Happening altogether. That means there is jointed. They are jointed. A1 and A2 jointed. This is why this is the common region. But in this blank, A1 is happening, but A2 is not happening here. In this white portion, A1 is happening, but A2 not happening. A2 portion deleted. Okay, cancelled. Similarly, for the big ball of A2 events, the white portion will be what? A1 is not happening here. Okay, all this whole are A2 portion. Okay, so A2 is happening in this region and A1 is not happening because A1 is deleted by this portion. Okay, so this white portion is this and this white portion is this. So A1 can be represented as this plus this. Okay, A1 equals to what? This plus this from the diagram, and A2 equals to what? This white portion plus this black portion, right? This shaded portion and white portion plus will be A2, and this white portion and this shaded portion will be A1. This is why we have written this from the figure. Probability of A1 what will be? Probability of this portion plus probability of this portion, and probability of A2 what will be? Probability of this portion plus probability of this portion. Understand? And adding these two, we get probability of A1 and A2. Okay, adding this plus this, we can write probability of A1 plus probability of A2 will be just taking sum. This plus this equals to what? This plus this plus this plus this. Adding equation into, there are 4 terms. Now probability of A1, A2 plus, remember it, probability of A1, A2 not happening, and probability of A1 not happening but A2 happening. So this can be written as, actually plus means what? Union. Remember it. So probability of this plus probability of A1 and A2. A1 and A2. So probability of A1 plus A2 equals to probability of A1 plus probability of A2 minus probability of A1, A2. But this formula for only two events, A1 and A2. In set notation, this equation can be written as set notation. We can write plus for what? Union. Okay. In set notation, we can use union for plus sign, and for into sign, intersection. Okay. So probability of A1 union A2 when happening altogether equals to probability of A1 plus probability of A2 minus probability of A1 intersection A2. This is the set notation formula. Again, let us consider two events, A1 and A2 plus A3 are happening altogether. If we consider these two, And if we use A1 for A1 here, and for A2, if we use this A2 plus A3, then we can write this formula like this. Same. So probability of A1 plus probability of A2 plus probability of A3, this one. Okay. So actually, probability of A1 plus probability of A2 plus probability of A3 minus probability of A2 A3 happening altogether, minus probability of A1 A2 happening altogether, minus probability of A1 A3 happening altogether, plus happening all events altogether. Since the events, this A1 A2 A1 A3 are equal to A1 A2 A3, A1 and A1, there are two A1, but in intersection we can write only A1. Okay, so probability of all four these events here A1 double. Okay, so we can write probability of A1 in a single form. That means probability of A1 A2 A3 and this equal in set notation. Remember it from the diagram also. So therefore probability of happening all three events equals to A1 equals to probability of A1 plus probability of A2 plus probability of A3 minus probability of A2 A3 happening altogether minus probability of A1 A3 happening altogether minus probability of A1 A2 happening altogether plus all events happening altogether. So in the above result can be generalized as for n events. That means for 3 events we can write the formula for 3 events only, A1 A2 A3. So for n k times of events, that means A1 plus A2 plus AK dot AK, this formula can be generalized as summation I equals to K probability of AI. This is the probability of A1 A2 A3. That means we can write summation probability of I equals to 1 2 3 here. Okay, and these are not I equals to I and J equals to 1, but not equal 2 and 3. This is plus dot dot minus 1 k to the power k minus 1 minus 1 to the power k minus 1. Probability of all happening altogether. This is the plus sign. Okay, and this is actually we can write also the set notation for this. We can use union for plus. Summation I equals to 1 to k probability of AI minus summation Ij, not all are equal, Ij are not equal, but Ij relatively prime. That means no common element. So then in set notation we can write this. This is the actually additive laws of probability for not mutually exclusive events. So let's roll a die once. The total sample space is 1 2 3 4 5 6 equals to 6. So probability an event will occur. What is the probability? You will roll an even number. Okay, so since there are 3 ways to get an even number, rolling a 2 4 or 6, there are favorable case. How many? Favorable 2 4 6, that means 3. So according to that definition of classical definition of probability of even number will be favorable spaces and total spaces. Total space how many? 6. This is why only half. Similarly, for the probability of getting any one odd number what will be? 1 3 5. So probability of odd number will be 3 divided by 6. Since 3 odd number and total space is 6, this is why we get similarly for the even number. Now the word and in the probability means the intersection. Remember it. And means what? Intersection. So what is the probability that you roll an even number and a number greater than 3? Very interesting example. So this is the space expectation rolling an even number, and F is the rolling a number greater than 3. There are two events. One is for even number and other event is for getting greater than 3. So probability of E intersection F will be, intersection means and, remember it. So this will be favorable space how many? 2. Favorable 2. Rolling an even number how many? 2 4 6. And greater than 3 how many? 4 5 6. Okay. So from these two sets, one is 4, 5, 6, and another is 2, 4, 6. Common what? 2. Only 4, 6. Okay. So 2 is the favorable one. How can E occur? 2, 4, 6 for even number. And how can F occur? Greater than 3. How many samples? Sample space will be 4, 5, 6. So common will be the intersection. So intersection will be what? Only 4, 6. So 2 will be the favorable outcomes. So total outcomes, how many? 6. Total outcomes, there are 3 and there are 3. So total outcomes what? 6. So probability of getting rolling an even number and rolling a number greater than 3 will be 1 by 3, because E intersection F will be what? 4, 5. So the word or in the probability means the union of two events. Remember it. We have to use or for what? Union in set notation. What? So we can write an example as, what is the probability that you will roll an even number or a number greater than 3? You must know, is the sample space will be for even number 2, 4, 6, this and union means or. Remember it. And F will be what? 4, 5, 6. So union will be how many? 2, 4, 5, 6. That means 4 sample. How many outcomes? Favorable outcomes what? 4. And total outcomes what? 6. This is why probability of rolling an even number or rolling a number greater than 3 equals to favorable space divided by total space. Total sample space. So 4 by 6, that means 2 by 3. Understand everybody? What will be the independent events? Two events are independent if the outcome of event A has no effect on outcome of event B. Actually, there will be two events. One is A and another is B. And A is not dependent on B. Then these events will be independent events. Suppose it rained on Tuesday. Okay, and my chair broke at work. There are two events. One is it rained on Tuesday, and another event is my chair broke at work. Are not at all related to each other. They are independent events. When calculating the probabilities for independent events, you multiply the probabilities. For independent events, you have to multiply the probabilities. Suppose, let us take an example. Let event A, today it will rain in Delhi. Okay. Another events B, today I will reach office late. This is the second event. Third event C, possibly of both event A and B. That means today it will maybe rain and maybe reach office late. So happening altogether, what will be the probability? Suppose we are given probability of A will be 0.1 and probability will be B will be 0.02. Hence probability of C will be just multiplication of the independent probability. So multiplying probability of A and multiplying probability of B, we get the L together. Understand? Now conditional probability, what will be? The conditional probability of A, of an event A where given B. If B happened, then what will be the probability of A? It will be the conditional probability. So the conditional probability that an event A will occur given that another event B has occurred already. Yes. So formula for that, probability of A if B happened. Probability of A if B happened equals to probability of A intersection B. A intersection B means what? Happening altogether. Probability of happening altogether divided by probability of B. If just using this formula, we can write for conditional probability. This is the formula for this. You can write now. Probability of A if B happened equals to probability of happening altogether, that means A intersection B divided by probability of B. If B in denominator, then probability of B will be denominator. If A is denominator, then probability of A will be denominator. Remember it. And this is the Venn diagram for that. This is the common region, and this is the probability of happening A, and this is the another probability of B happening B, and this is the shaded region will be the actually common region, and this is the probability of A intersection B. Remember it. For example, try to understand this. So complement of E and is the set of all elements in the same sample space in that are not in E. That means a complement of set E, event E will be this event will be cancelled from the total sample space. So if E is the success and E complement E is the failure, then total probability will be 1. And this is more often used in the form probability of failure will be 1 minus probability of success. So if we know the probability of rain is 20% or 0.2, same words, then the probability of the complement will be no rain. What will be? 1 minus 0.2, that means 0.8. That means 80% probability will be the no rain. Understand this example? If we know the probability of rain is 20%, so not happening will be what? 80%. This is actually complementary events. Example of complementary events. And in gambler's fallacy, actually in gambling and in chess, cards, different types of game are also depending on probability. Depending on probability. Okay, this is the example for non-mutually exclusive events and mutually exclusive events. In mutually exclusive, there is no common elements between two events. That means no common space and common outcomes. That means intersection will be 0. And here intersection will be not equal to 0. This is the actual difference between non-mutual exclusive events and mutually exclusive events. And this is, there are different multiplication laws, theorem. If A and R B are independent events, then the probability of the simultaneous occurrence of A and B is equal to the product of their individual probabilities. If independent events, A and B are two independent events, then probability of happening altogether, that means A intersection B equals to multiplication between A and B with happening independently. Okay, probability of A into probability of B. If A and B are two independent events, then the probability of the simultaneous occurrence of the A and B is equal to the probability of one event multiplied by the conditional probability of the other events. That means you must know about this. In conditional probability, we got this probability of B if A is happened equals to what was? Probability of A intersection B divided by probability of A. Same as the formula of previous one. And this is the practice problem we will discuss in next class. This is the bias theorem, very important theorem. In next class, we will discuss about this theorem and try to prove this theorem. Okay, till then, bye for today. Thanks to everybody. Okay, today we have learned actually the introduction of probability and basic concepts of probability. We have discussed different types of definitions related to probability and the additive laws of probability and multiplicative laws of probability, independent depends, conditional probabilities, and try to prove the additive laws of probability. In next class, we will discuss about the bias theorem and the application of probability also. Okay, thanks to everybody.